Okay, we're going to work with tangents and derivatives. We're going to do the even numbered questions. So we're going to get started on that. We already did the odds. So we're going to try to find, in this example, again, we go back to what the instructions say. The instructions say determine the equation of the line tangent to the curve at the indicated point P. So there's a point there. We want the equation of the line tangent to the curve. So, like we did with the odds, looking for, I guess we need to find L tangent, this equation though. So the equation is y minus y1 is m tangent x minus x1. So here's the one and only point. And so we get y minus 3 now is m tangent x minus 5 because, again, the x1 value is 5 and the y1 value is 3. So we're going to need to use this. We're going to bring this down here, okay? Alrighty, let's try to bring that all down. So now, ladies and gentlemen, we need m tangent. And the definition of m tangent is the derivative of y evaluated at x equals 5, because that's the x coordinate. That's x1 here. So it's going to be 5 now. Okay, now your function, though, is what you see here. Y is the square root of x plus 4. So then y prime, let's double check here, will be the derivative of y. We're going to write y as x plus 4 to the 1 half. And so that derivative is 1 half x plus 4 to the minus 1 half, now times the derivative of 1 by chain rule. So this really is 1 over 2 square root of x plus 4. So if we evaluate this at x is 5, we're going to get y prime. So 1 over 2 square root of 5 plus 4 now. And that's going to be m tangent. So let me just write it that way, okay? We're going to write this as our definition of m tangent. It's like we did earlier. And this gives us 1 over 2 square root of 9, which is 1 over 2 times 3, or simply 1/6. So my m tangent is 1/6. This is what we were looking for. Okay. So let's replace this with 1/6. Now, doing some arithmetic on this here, we copy that. Okay, we're going to get y minus 3 is 1/6 x minus 5/6, because we're going to distribute the 1/6. So if I add 3 to both sides now, we get y equal to 1/6 x minus 5/6 plus 3. Multiply the top by 3 and the top by 6, the bottom by 6. So y is 1/6 x minus 5/6 plus 18/6. And so y will be 1/6 x plus 13/6. All right. So here's our L tangent now. So let's go back and let's make sure we have that square root function. Okay, and then I'm going to put this in Desmos in the browser here. Let's find out where this function will be. Let's go to the browser. And it looks like it's here. Here's the point. Okay, we're going to label it. Now let's go all the way down here. We're going to put the derivative now. And let's see. That's not what we want to see. Let's go back to the iPad. Let's get rid of this. Where are we at? Yeah, we don't want that. Okay, let's go back here to the browser. There we go. And then we're going to add down here that derivative of y equal to, I guess it was over here earlier today. Y equal to 1/6x. So 1 divided by 6. Come out of there, x plus 13 divided by 6 now. And there you go, ladies and gentlemen. That's what we're looking for, in case you guys don't know. Okay. As you guys can see here, if we move this out of the way, that red line is Al tangent at the point 5, 3. All right. Okay, so you guys seen this here. Now, let's do number 4 now, since we are doing now the evens. Earlier we did the odds. And here's our function, if we can see that. All righty. Number 4. Y equals x minus square root of x at the point 4, 2. We're going to try to find that tangent line, the equation of the tangent line. And that's Al tangent, so it's y minus y1, which is m tangent times x minus x1. So here's your location, here's your point, your xy coordinate for 2. So that becomes y minus 4. This is your x coordinate. M tangent, I apologize. We have to do the y coordinate, which is 2. And then this will be x minus the 4 value, because that's x1. So we have to do the y coordinate, right, which is 2. The x coordinate is 4. The y coordinate is 2. And now we're okay. Now we have to find, again, like always, m tangent. Here we go. All right. M tangent is y prime evaluated at x equals 4. And y is x minus the square root of x. So let's find m tangent. Okay, so y prime will be the derivative of x minus x to the 1/2. So the derivative of a difference will be the difference of our derivatives. All right, so this will be 1. And like I said to you guys, I think you want to memorize this one. It shows up a lot. So this is y prime. So m tangent will be 1 minus 1 over 2 square root of x. And you evaluate that when x is 4 now. So we're going to plug in 4 for x. And we get 1 minus 1 over 2 square root of 4. 1 minus 1 over 2 times 2, which will be 1 minus 1/4, 4 over 4. So m tangent becomes 3/4. There you go, ladies and gentlemen. And I guess earlier we were coloring it red. So m tangent is 3/4. We're going to use that value. Let's go put it up here. And now we're going to do some arithmetic. We're going to get this equation of the line, and we're going to see it in Desmos there. So y minus 2 becomes 3/4 x minus 4. Let's distribute. Y minus 2 is 3/4 x minus 3. And we can add the 2 now, and you get y becomes 3/4 x minus 1. There's your altangent. All right. 3/4 x minus 1. So altangent 3/4 x minus 1. Okay. So let's go back and look for the curve. Here it is. Here's the point. So let's put 3/4 x minus 1. And let's go take a look at this. And so, ladies and gentlemen, there is the curve in blue and the tangent line in red at the point 4,2. There it is. Okay. All right. Let's see the next one. Let's see number 6, I guess. Let's see what's going on. Somehow it's weird. Okay, number 6, we have this 1 over sine plus cosine at the point 0, 1. It looks like there is no restriction on that domain, but it doesn't really matter. We're looking at, again, finding altangent, which will be y minus y1 equals m tangent of x minus x1. Here's the x and y coordinate of what we need there. So the x coordinate is going to be 0, and the y coordinate is 1. So we get y minus 1 becomes m tangent x minus 0, or we can say y minus 1 m tangent of x. So we just need our m tangent again, and we will solve for y to get that equation. So let's kind of get what we need here. Okay. So now m tangent, by definition, is the derivative of y evaluated at x equals 0, I believe, right? Yes, it's 0, 1. So the x coordinate is 0. The y coordinate is 1, okay? So, all right. Now, the thing about this is y prime, our function is 1 over, let's see what that is, sine plus cosine. So 1 over sine plus cosine here. All right. And we're going to have to use quotient rule now. All right. So let me kind of get some space here. Sine plus cosine squared. Bring up your sine plus cosine. Okay, now we're going to take the derivative of the constant 1 minus the 1 times the derivative of the sine plus cosine. And I ran out of space, so I'm going to put sine plus cosine here. Okay, so the derivative of 1 is 0, and 0 times anything will be 0. So I just need the derivative here, if you can see that, of sine plus cosine. Derivative of sine is cosine, plus the derivative of cosine is actually minus sine. So my derivative is cosine minus sine over sine plus cosine squared. We're going to evaluate this at x equals 0. So when you plug in 0 now, you get cosine 0 minus sine of 0 over sine of 0 plus cosine 0. This will be to the second power now. So we just have to know the value, I should say the trig values here. Cosine of 0, that's where you start. This number is 1 and sine 0 is 0. Sine 0 is 0 and cosine 0 is 1. So ladies and gentlemen, this is really your m tangent, by the way. So let's write that down here. So m tangent will become 1 minus 0 over 0 plus 1 squared. So that's just going to be 1 for m tangent. So we got 1 over 1 squared. M tangent is the number 1. So remember, we were keeping this in red. And if this is in red, this number here is 1. So we get y minus 1 is 1 times x. Let's bring that all the way down. Okay, m tangent is 1. And this means y minus 1 is just x. So add 1. And this is out tangent. All right. Y is x plus 1. Okay, so let's go to the browser now and try to see this in Desmos. If it lets me. I'm going to change the tangent. You guys remember that's going to be just an x plus 1. But this is not the same curve. We got to find the right curve here. Get rid of this label. Here's our curve. Here's the point. We're going to label it. And, okay, what did we do wrong? Is that the right? Y is 1. Sine is cosine. Cosine minus sine. All right. Is that 0, 1? All right. Is it negative 1 as the slope? Let's go back. Let's check our work, ladies and gentlemen. Y is 1 plus sine of a cosine. The point is x is 0, 1. Okay. So y minus 1 is m times x minus 0. Everything looks like it's okay now. So cosine of 0 minus... Oh, I see this here. There is a negative sign right in here. Okay. There it is. This is negative. Okay, let's find it here. Negative, positive. Because right here, see, this is where we can't really see what we're doing, which is not good. All right, so we couldn't even see what we were doing there. Let's get that. All right, so there's a negative 1 times cosine. So it's negative cosine plus sine here. So that is negative. Okay, negative cosine here, plus. There it is. We can't even see it because we couldn't write it, so that's not fair. So yes, it's a -1 for m tangent. So this will be -1. This will be negative, and this is negative. Now it's going to make a lot of sense. So your m tangent, ladies and gentlemen, is -1. Let's put that there. And we found it, and it's right here, -x plus 1. So going back to the browser now, it'll make a lot of sense. Put that negative sign now. And there you go, ladies and gentlemen, in the browser. Okay. There it is. That's the equation of the line, tangent to the curve at the location 0, 1. Yeah, the other curve was not tangent. It wasn't kissing. So here you guys go. Okay, we found the error. Good, good. All right. Let's do the next one. All right, so that was number 6. We're going to go to 8. We already did 7 earlier. Now we're going to try 8, ladies and gentlemen. Okay, we're trying to find the equation of the line, tangent to the curve. This time it's at the point pi 3 for the x-coordinate and 1. This is what they gave us. And they gave us a restricted domain. Didn't really matter, but for finding L tangent, y minus y1 is m tangent x minus x1. So here's the x-coordinate, the y-coordinate. So the y-coordinate is 1, and the x-coordinate is pi over 3. So let's write this all down, or bring it down. Maybe we'll just bring everything down. So you have y minus 1 is m tangent x minus pi over 3. We need m tangent. Now, m tangent, let's see that. M tangent will be the derivative of y evaluated at x is pi over 3 now. Okay, so we have to find the derivative here of secant minus 2 cosine. Here's the function y. We have to differentiate this y function. If I could get a highlighter. All right. Okay, secant minus 2 cosine. Secant minus 2 cosine. M tangent is the derivative, or let's do it this way. We just say y prime. So it's the derivative of secant minus 2 cosine. So when we differentiate derivative, we're going to do the derivative of a difference is difference of derivatives. And pull out the constant. Let's find these derivatives here. Okay, derivative of secant is secant tangent. So I'm going to write down secant tangent. The derivative of cosine is minus sine. So we're going to see everything in this problem here, which is good because then we're not going to make that silly mistake we did in the prior even. So minus the minus makes that a plus. All right, secant tangent plus 2 sine. This is m tangent because we have to evaluate this at pi over 3. Secant pi over 3, tangent pi over 3, plus 2 sine pi over 3. Now, what in the world is pi over 3, right? That's 60 degrees. So you might have to draw a right triangle here. Okay, if you guys remember this, equilateral triangle, 60, 60, 60. Okay. 2, 1, square root of 3. And so we're going to use this 60 degree here. So you guys know we're going to use that right triangle here. $60, square root of 3, 1 and 2. So secant is a reciprocal of cosine. Cosine 60, if you guys recall, is 1/2. So secant is the reciprocal, which is 2. Okay, so I just want to note, okay, cosine of 60 is adjacent 1 over hypotenuse. So we're correct. So this will be 2. Now, tangent of 60 degrees is opposite over adjacent. So it's just the square root of 3. Sine of 60 degrees is opposite over hypotenuse. Okay, so we're looking at this right triangle. Now, all together then, you can say, what is our M tangent? M tangent will be the secant, this is 2. Tangent is the square root of 3 plus 2 times the square root of 3 over 2. So let me double check here, okay? We don't want to make a mistake. So this one we know is 2. Tangent, we said, was square root of 3. Sine 60, square root of 3 over 2. So it looks like 2 square root of 3 plus square root of 3 makes that 3 square root of 3. So M tangent is 3 square root of 3, ladies and gentlemen. Okay. All right. Now 3 square root of 3. So that means 3 square root of 3 here. All right. I'm gonna do a little. I'm gonna erase a little here. Didn't do that before, but you have that in the video. So y minus 1 is 3 square root of 3x minus 3. If I put 3 square root of 3 pi over 3, the 3's cancel. Okay? So I want you guys to see that, and I'm just going to put minus 3 minus the square root of 3 pi. And then don't forget to add 1 to both sides, or translate. Move the 1 over here. 3 square root of 3x minus the square root of 3 pi plus 1. This is my L tangent. Okay. You guys can see that there. So let's go back to this curve. Y is secant minus 2 cosine. Let's find it in the browser. So let's put that here. 3 square root of 3. Let's bring that out. That'll be your x. Minus the square root of 3. Bring that out with the pi. And don't forget to add 1. Let's see if this worked out. Yes, it did. It worked out pretty well for us. Okay, so you guys can see this in the browser maybe, right? You see this? Okay. I don't know. Bring it in maybe. See how that works. Yeah, I don't know. Anyway, ladies and gentlemen, pretty good. It does look good. It does look like it's a tangent line, so we are on the right track. Okay, so let's do the next even question. We're doing the evens now. Okay, so I'm going to go down to number 10. Now, number 10, starting again here at number 9, they're going to want us to determine the location of horizontal tangents for all the questions that come after 9. So now we're trying to find the horizontal tangents, which means the tangent line that you guys have again has a slope. M tangent is going to be equal to 0. So your derivative is 0 and you solve for x. So again, here, that means y prime is 0. Solve for x. So I'm going to differentiate. I'm going to have to find my derivative of y, which is 12x minus x to the third power here. And I set that equal to 0. Okay. So let's see what this derivative is. And if you look at the curve again, just to kind of remind you guys, I can see I have a horizontal tangent down here, right? Somehow. I'm in a valley, and then up here, I'm at the top of a hill. So I want to share with you guys that before I do all my algebra. Well, looks like I have horizontal tangents there, okay? So you guys can see that there. All right, let's find these derivatives. So this will be 12 minus, well, if we want to do every detail, use your operator notation. Derivative of a difference is difference of derivatives. You know, let's use our properties here of derivatives. This is maybe helpful for some. The derivative of x is 1. The derivative of x cubed is 3x squared. So you're going to get now 12 times 1, which is 12, minus 3x squared equals 0. I'm going to use intermediate algebra. Okay, I'm going to use the square root formula. This gives me x squared equals 4, which means x will be, by the square root formula, plus or minus square root of 4, or x is plus or minus 2. So x will be positive 2 in one case, and x will be negative 2. Those are my two x coordinates now. Okay. So there's two solutions here. I just want to kind of fill that out, and maybe it's better to just put them down there. Okay, so you can see that. And I don't know where that 2 went, but there are your two solutions. So it does look, here's where negative 2 is. And here's positive 2. So it does look correct. Okay, when x is negative 2, we got to find that y coordinate. Okay, so this location, negative 2y, and then up here, positive 2y. So we got to find those values. Now, here's my y. Plug in 2. So if x is 2, I get 12 times 2 minus 2 cubed, which equals 24 minus 8. And 24 minus 8 is 16. It's kind of late. So it does look pretty good. That does look like it's 16, by the way. So let's actually move this up a little bit. So this is like where 16 would be, in case you guys can't see. So yes, When x is 2, y definitely looks like it is 16. There's the first location. First point. Now, let's find x is negative 2. We're going to do the same thing, but now for x as being negative 2. So, x is negative 2. That means y is 12 times negative 2 minus negative 2 cubed. Or y is negative 24 minus a minus 8. Y is negative 24 plus 8. Negative 24 plus 8 is negative 16. So x is negative 2, y is negative 16. So there, it does look also like that's negative 16 down here. So, all right, looks pretty good. So, ladies and gentlemen, those are the two locations here where you have horizontal tangents. That means the slope is 0 here. Okay, this is your process for horizontal tangents. And that's number 10, okay? Pretty good, not too bad. I like that one, number 10. All right. Let's do number 12 here. And you go, oh, number 12 is interesting. Yeah, it's going to be interesting. I mean, the domain here, this is cosine over 2 plus sine x. It's periodic because sines and cosines are periodic. They did not restrict the domain, so let's see how that pans out. Oh, it might be interesting. That means there's probably infinitely many locations where you have some horizontal tangents. You're not looking at every, location here. And in fact, I can see a few of them. So I'm looking here at the hills and valleys, okay? Remember that? Hills and valleys is where you're going to find horizontal tangents. Hills and valleys. All of these are horizontal tangents. So that means m tangent is 0. So what you're going to do is you're going to take the derivative of that function and set it equal to 0 and solve for x. It's going to be a trig equation. And you're going to see all these horizontal tangents have that 0 slope here. Okay? So let's find the derivative. So I'm going to differentiate now cosine over 2 plus sine. We're going to use the quotient rule. Two plus sine, we're going to square it. 2 plus sine, and take the derivative of cosine. Minus cosine, and let's be careful. Whenever we run out of space there, I'm going to get rid of that. I get a little nervous. Easy to make a mistake. All right, so let's not forget. Okay, I have to differentiate 2 plus sine here. Let's be careful now, okay? So derivative of cosine is minus sine. And derivative of 2 plus sine is cosine. So, ladies and gentlemen, we're going to get this negative 2 sine x minus sine squared x minus cosine squared x in the numerator. And this will be 2 plus sine x in parentheses squared. So I just got y prime. Let me kind of do some, if I can try to get what I need. No, I just want the lasso. I'm going to move this over. So the algebra is going to be over here. Few things to say. Minus 2 sine x. This would be minus sine squared plus cosine squared. Okay? And that's my numerator over 2 plus sine x squared. Now, this is 1. And so, ladies and gentlemen, that first derivative is negative 2 sine x minus 1 over my 2 plus sine x squared. We got to set this equal to 0, this derivative. So I'm going to say, okay, this equals 0 here. Now, this is what I want you guys to remember, that if you ever have a rational and it equals 0, then what that means is your numerator is 0. That's what this means. So I get a triangle over a square is 0. And what that means is your triangle has to be 0. It means your numerator needs to be 0, and that's what that is. So you're going to end up getting negative 2 now. Let's get that numerator up here. Negative 2 sine x minus 1 equals 0. This is a trig equation. Okay, so you got to solve that trig equation. Negative 2 sine x, if I add 1 to both sides, will equal 1. Divide both sides by negative 2. And I end up getting sine x equals negative 1/2. All right, now this is going to be a little bit of a problem. Okay. Or is it? So sine x is negative 1/2. All righty. All right. Now, let's think about this here. A few things. I got to go back to trig. And quadrant 1, quadrant 2, quadrant 3, quadrant 4. This is solving a trig equation. All students take calculus. Now, what this means is sine is negative in quadrant 3 and in quadrant 4. Okay? Because you're saying right here sine is a negative number. So we just have to find now the angle, I guess, in radians. And to do that, we have to find that reference angle. So when I teach a trig course, and I highly recommend you take trig, because if you're going into STEM, trig is your language. You have a lot of trig in STEM. So sine x becomes positive 1/2, and this is the reference angle. So we need to know what the reference angle is. So I'm going to go back to my definition here of a right triangle where sine is going to be, that's going to be x bar. That's my reference angle. Opposite over hypotenuse. Now this makes this a square root of 3. So I recognize this special triangle and I go, oh, that's 30 degrees. So pi over 6 is the reference angle. Now this is where sine is positive. So it's 30 degrees here. Okay, but the real angle is negative, which means it's in the opposite quadrant. It's really in quadrant 3 and quadrant 4. There's 2, so this is 60 degrees. So if my reference angle is 60, which is pi over 6, remember the quadrant 3 angle will be pi plus pi over 6. And the quadrant 4 angle will be 2 pi minus that pi over 6. There's equations here. So I'm going to have to do some more arithmetic, okay, solving trig equations. So the angle is actually 7 pi over 6. And this is 12. This will be 11 pi over 6. Okay. Now, this is going to be extremely important, ladies and gentlemen. If I can get a blue highlighter. Let me remind you guys. These are solutions only with the restricted domain. These are particular solutions from 0 to 2 pi. Okay, so you have two solutions in 0 to 2 pi. The problem is they never restricted your domain here. So we want general solutions here. Okay, so we need these general solutions. All right, well, let's see. I want to take a look at something. 7 pi over 6. So 0 to 2 pi, just so you guys know, is like from 0 to 6 point something. And so in that restricted domain, I will have, if it's 0 to 2 pi, a solution here, a solution over here, just so you guys know. And I want to point this detail out. So the first solution here is 7 pi over 6. I just want to, it happens when x is 7 pi over 6, and this happens when x is 11 pi over 6. Does that seem about right? Yeah. Okay, so all right. So let's take a look here. Pi over 6 is 30 degrees. Remember that? This is about 30 degrees. I just want to say. Okay. So 7 times 30 divided by 6. Well, 7 times 30, sorry. So we got 210 degrees. Okay, and we have 330 degrees. So it looks pretty good. So these are the solutions from 0 to 2 pi. Now, this isn't every solution. So I think I could do a couple of things here. Let's see, what mode are we in? Let me see. Cosine. Yeah, I think I'm just gonna do that. I'm gonna just do something here. Mode. All right. Well, here's a way you can do this, right? So remember, we need general solutions now. So I'm going to do it this way. I'm going to kind of do the general solution. This will be plus 2n pi. Okay? So if you said, Mr. Judge, I want the real x coordinate value, generally speaking now, because we did not restrict the domain. Well, you have the general solution for that first 7 pi over 6. This is like the first solution. Here's your second solution. You take 11 pi over 6 plus 2n pi. N is an integer. Now, they want locations. They want points. So what I can say is try to do it this way, maybe. Let's just be a little sneaky about this. I'm not going to get those answers. It's kind of late. So here's my first solution. So this is what I mean. You got the x coordinate solution right in here. There's your x. And then this is going to be the y coordinate. Say this is f of that value. So the other one is 11 pi over 6 plus 2n pi. And then we're going to say f of 11 pi over 6 plus 2n pi. N is an integer. And this is going to give us the y coordinate value. Okay, so here's the x coordinate. There's the y coordinate because we have an f of that number. And this is our f. So, we pretty much generally plug that in there. Okay, cosine and then plus 2 plus sine. So it's kind of late for me, so I'm just going to say, hey, you know what? That's okay. Now here's the locations, ladies and gentlemen. There it is. This is for these trig equations. So whoever said trigonometry is not in calculus, probably some counselor who never took calculus. All right, there you guys go. You can kind of find those values. I would get them personally, but like I said, it's kind of late. And it isn't too hard. Number 12. Anyway, nice trigonometry. Let's try number 14 here. All right, now in 14, it's a little bit different. And here's the question. They're saying determine the points on the curve that has a slope of a tangent line equal to 4. So slope of the tangent line, that's m tangent. And that said, they're saying determine points on the curve where it equals 4. So m tangent equals 4. That's what they just said. Okay, and m tangent is the first derivative. So m tangent is y prime. That will give us a slope. So I need the derivative of the function, and the function is x squared plus 3x minus 7. So by properties, we get 2x, 1, 0. M tangent is 2x plus 3. So we're going to set this m tangent equal to 4. Okay? Okay. Determine the points on the curve. We need an x coordinate value, and then we'll get the y coordinate. So to say m tangent is 4 now, but m tangent is 4. That means 2x plus 3 must equal 4. So solve this for x. 2x is 1. X is 1/2. So that's the x coordinate where you have m tangent equal to 4. That's the x coordinate. We need the y coordinate because they want the points. So you say, how do I get the y coordinate? Well, if I can get a pencil, if x equals 1/2, then y will be 1/2 squared plus 3 times 1/2 minus 7. So, I mean, I could do the arithmetic. I can. 1 divided by 2 squared plus 3 divided by 2 minus 7. Let's see, ladies and gentlemen, go to math fraction, and that's negative 21 over 4. All right. So y is negative 21 fourths. So x is 1/2. Y, okay. So here's your answer. X is 1/2 and y is negative 21 fourths. There's your location. And I'm going to look for that curve. Y is x squared minus 3x minus 7. So in the browser, get rid of this, get rid of this, get rid of the tangent. What was that curve? X squared. X squared plus 3x minus 7. Oh, there it is. And what I'm going to do here is this. I'm going to put that point of 1/2. Okay. About there, comma. And I think that's negative 21 fourths. All right, let's just see something here. All right. Well, label that. Label. So, ladies and gentlemen, you might be able to see this here. Yeah, there it is. So at that location, you actually have a tangent line that has a slope of 4. We didn't get the equation of it, so that's not what they're asking. They're just saying determine the points. Those are your x and y coordinates right here. So anyway, I just wanted to show you that that's on the curve. So interesting question, number 14. All right, well, we did 15. And we got 16, which is a very similar question. It says show that the curve here has no tangent line with slope equal to 4. What does that mean? That means m tangent could never equal 4. Okay, show that this curve has no tangent line that has a slope that is equal to 4. M tangent does not equal 4. We need M tangent. So M tangent is y prime, which is that derivative with respect to x of y, which is 6x cubed plus 5x minus 3. And by properties of derivatives now, right? So let's do some properties of derivatives. 6 times the derivative of x cubed minus 5 derivative of x minus this 3 here. So this gives you a 3x squared. This gives you a 1. This gives you a 0. So m tangent is 6 times 3x squared minus 5 times 1, or m tangent is 18x squared minus 5. Looks like, is it minus 5? I think it's plus 5. I think that's a plus. It's a little late. Let's double check. Okay. So now they're saying that this thing could not equal 4. I wonder why not. This can't be 4. Well, let's say it is 4. Okay, let's say it's not. They're saying 18x squared plus 5 could never be 4. Subtract 5, subtract 5. I see. 18x squared could never be -1. And if I divide by 18, what they're saying is x squared could never be a negative 1 over 18. Now, yes, there's no real solution here. Okay, there's no real solution. There's complex solutions. You can have complex solutions, but no real solution. So, yeah, that is a true statement that x squared is never equal to a negative number, any negative number, if we're considering real numbers. So we say no real solution, or sometimes they say there is no solution here. So, if the slope could be 4, this would be solvable. But because it's not 4, it's not solvable. So yes, that's what they're showing us. So we did show that you could never have a slope that's positive 4, and that's how you do it, ladies and gentlemen. You get an equation that's not solvable. I mean, so even if we set it equal to 4, like we started to say, maybe we'll set it equal to 4. You go, oh, what if it's equal to 4? What if it's equal to 4? Hey, you go, Mr. Judge, does x squared equal a negative number? And I will say, no, there's no solution. So this is what we go back and do. So the slope could never be positive 4. And I think that concludes all of the questions. Did we do? Yeah, that includes all of them. There is no 18. Oh, there is an 18. All right, I'll do 18. It's a little late, but I'll do it. Okay. 18. Find the equation of the normal line to the curve at the point 2, -2. So what I'm going to do here is I'm going to find the tangent line, okay? And I'm going to share with you guys something here about this. Let's first get the tangent line, because the normal line, called L normal, I want you to write this down here. These two lines, the tangent line and the normal line, so you guys know, are perpendicular to one another. So here's the idea of being perpendicular. Find the tangent line. It will have a slope. We call the slope m tangent. The normal line, maybe we'll make it pink, purple. Come on. It will have a slope. And that is m normal. Okay. So I want you guys to know this. Go back to beginning algebra. If lines are perpendicular to one another, right? If you guys remember, m1 times m2 will be -1. So this is the equation that you guys will use here, meaning find the tangent line. And if you do that, you're going to find the normal line slope. So find the tangent line, find the equation of the normal line. So the equation of the normal line will be what we have here. Y minus y1 is m normal times x minus x1. And it's at the point 2, 1. So this is the x and y coordinate. Okay, the one and only point, 2, -2. So say y minus -2 is m normal times x minus 2. We got to get that normal line here. Okay, the slope, m normal, is what we need, because that's going to give us the equation of the normal line. So we're going to call that L normal. Maybe we'll put it in purple. But in order to find that slope, we need the slope of the tangent line at the location. So m tangent, and we'll show you how to do that. So, all right, m tangent is the derivative of the function evaluated when x is 2. And the function is x minus x squared over here. Okay. So y prime is the derivative of x minus x squared. So y prime will be d dx of x minus d dx of x squared. Okay. So we have 1, we have 2x. So y prime is 1 minus 2x. Evaluate that as x is 2. So the m tangent is 1 minus 2 times 2, which is 1 minus 4, which is negative 3. Okay. So we have the tangent line. It's negative 3. So if he said to me, well, how do we handle this relationship of being perpendicular? Because a tangent line is perpendicular here. These lines will be perpendicular. So if I just want to kind of note something here. I'm going to do this here for you guys so you guys can see. The tangent line, y minus y1 is m tangent x minus x1. I'm going to get the tangent line. So 2, negative 2. So this will be negative 2. This will be 2. We found out that this is actually negative 3. So let's get the equation of the tangent line. So that becomes plus 2 minus 3, x minus 2. Y plus 2 is negative 3x plus 6. Subtract 2. Y is going to be negative 3x plus 4. So let's get that tangent line so you guys know. I'm going to show you in Desmos here something interesting. The normal line. Okay. So we're going to go back to that curve here, which is parabola. Y is x minus x squared. And I'm going to find that tangent line to the curve. And I'm going to show you, we'll talk about the normal line now. So get rid of that. I think the function is down here. Here's the point. And I'm going to put down here in red y minus 3x plus 4. And there's an equal. And sure enough, it's in red. And we want to label the location. Now, you guys can see, first of all, that there is a tangent to the curve at the location. And that's red. That red line is our tangent. You might say to me, well, we need the normal line. Well, the normal line is perpendicular to the tangent line. Go back here. Go back to what we originally said, and that the normal line and tangent line are perpendicular, also known as being orthogonal. So if you multiply the slopes together from beginning algebra, perpendicular lines, right, have a product of the slopes that's negative 1. So let me remind you guys, what does that mean to have perpendicular lines? If this is L1, this is L2, okay? These lines have this 90-degree angle. These lines, L1 is perpendicular to L2. This is what they're talking about. And I already have one of the slopes being negative 3. So I'm going to say, let's let this be negative 3. Well, that means from algebra, negative 3 times this m2, which is your normal, m2 would be negative 1, negative 3. m2 was positive 1/3. So that's the key. That's the slope of the normal line. We're using all of these nice relationships from beginning algebra, that the product of the slopes is -1. So if the first slope is -3, the second slope will be 1/3. So this is 1/3, ladies and gentlemen. And now you get y minus a -2. So Al normal y plus 2 is 1/3 x minus 2. Let's go back and double check. Did we plug this in? Yes, we did. So let's just do some arithmetic now. So the normal line, 1/3 x minus 2/3, subtract 2, 1/3 x minus 2/3 minus a 2. We multiply the top by 3 and the bottom by 3. So y will be 1/3 x minus 6. It looks like minus 8/3. So, ladies and gentlemen, this is the equation of the normal line. It is perpendicular to the tangent line at that particular point. Okay, I'm going to show you in Desmos that this line is perpendicular. 1/3 x minus 8/3. It's perpendicular. 1/3 x minus 8/3. So, we moved it. Okay. Let's go down here. Y equals 1/3 x. And then that's going to be minus, I believe, 8/3. And at the point, and I'm going to make that line purple. Okay. And I got to admit, maybe it's just too late. I don't even think those lines look perpendicular to me. Okay, -3 slope, positive 1/3. So y, so that's y plus 2 is 1/3 x minus 2. And I don't know. I don't think those lines look very perpendicular personally. So I'm gonna kind of find where is that error. X is 2, y is -2. Negative, x is 2. I mean, it looks good to me. Okay, they need these do, they should have, they look to be perpendicular. I don't know. That doesn't look perpendicular. -3 and 1/3. They are opposite and reciprocal. So the slope should be fine, and they're both going through the same point. Unless the tangent line is off, and we get 2. Sorry, let me stop there. So tangent, so y minus a minus. Yeah, my algebra looks good, but those lines do not look perpendicular, ladies and gentlemen. So I don't know. It looks a little bit odd to me. Maybe it's just this is late. So I'm going to call it a night. So, okay, take a look. Thank you. We'll see if we find the error.